Hey there, down to the last two questions, 38 and 39. We're almost done with this Regents. Hopefully this tutorial does help you in some way. Okay, the last two questions over here. Number 38 is a inequality question and is asking you pretty much to graph it out on this little chart graph over here on your paper, and to justify it if the point 1 comma negative 3 is part of the solution set. Well, first to graph it, you need to change that inequality. 4x minus 3y is greater than 9, right? And actually solve it in terms of y. Like isolate the y. Let's do so. Let's do a few steps over here. Let's first move the 4x over by subtracting it from both sides. This way you have just negative 3y is greater than negative 4x plus 9. And to get rid of the negative 3, we're just gonna divide by negative 3 on both sides. Okay. And we have y, and negative 3 divided by negative 4 divided by negative 3 is positive 4 over 3x, and 9 over negative 3 is minus 3. Okay. There's a key point you want to take note of here is whenever you divide by a negative number or multiply by a negative number, you need to change the sign. Right? This inequality sign greater than here, you need to actually flip it over, make it to a less than. Okay. Again, you always flip the signs whenever you divide or multiply by a negative number. And this is our inequality, and this is what we want to graph out. Okay, the y-intercept here is negative 3. So we're going to start off, whoa, now it's back. And we're going to start off at negative 3. Put a point there right on the y-axis. And the slope is 4 over 3, which means go up 4 and then right 3. Okay, that's my next point. Okay. And with 2 or 3 points, you can connect the dots. Right, make your straight line. There you go. You also want to label the axes, which is already labeled, and maybe just make some units there, showing the scale of this graph. So I'll put a few numbers here. And I made a mistake on the line because this is a less than sign, is actually going to be a dotted line, not a solid line. Okay, if y is less than or equal to 4 over 3x minus 3, then we put a solid line. Because it's not equal to, is actually a dotted line. So let me just change that. Yeah. Okay, that is my dotted line, right? And we need to shade in the side that is less than. And you can do this a couple ways. If you have a graphing calculator, you can actually graph it out and it'll do the shading for you. You can also pick a point left of the line, for example, over here, negative 2, 2, right? Plug in negative 2 for the x value, plug in positive 2 to y, and see if that's a true statement, right? And you can pick a point on the right side also, that's fine. But the quicker way that I find is actually look at the two sides and see which side is facing up, right? It's a little kind of difficult to show you on the video here, but if you think about, let's say where we're shading it and or drawing arrows that is perpendicular to a line, okay, right, on both sides of the line, right, which side is facing up and which side is facing down. The side is facing up more, the arrow is pointing up will be the greater than side. Right? This will be the greater than side. And the arrows as pointing down will be less than side. Okay, and that's an easy way to judge which way you should shade in. It takes a couple problems practices, but if you actually get this part, alright, it becomes a lot more faster and easier. Okay, so let me just erase these arrows I drew. Okay, and because we're looking for the less than side, like the problem over here, y is less than 4.3, I'm going to shade in the less than side, which is over here. And this is the side you want to shade in, and choose a different color, so it'll be easier on the eyes. Let's choose blue. And that's the side we shade in. And back to the second part of the question is asking for this point 1, negative 3, which is 1, negative 3 right here, right? It's 1, negative 3. Is this part of the solution set? Yes, it is, because it's in the shaded regions, right? And if you plug 1, negative 3 into the original equation, right, you should get a true statement. Okay. Right, you should get a number on the left side that's greater than 9. And there you go. And if you have a graphing calculator, this can be done and much more quicker, and but you still need to actually translate that graph and the graphing calculator onto the chart. Okay, number 39, the very last one. Consecutive integers. Right, consecutive integers are numbers that come right after each other. For example, 1, 2, 3, or 5, 6, 7, 8. Okay. In this case, we're talking about consecutive positive even integers. So we're talking about 2, 4, 6, right, 8. And if you notice, each digit goes up by 2 integers, or 2 units. Right, from 2 to 4 is a plus 2. Right, from 4 to 6, another plus 2. And that's how even and odd integers both work. Each digit that comes afterwards will increase by 2 units. So you want to talk about consecutive positive integers. Okay, the first integer, let's make a variable for that. Let's let it be n. The very next one, well, guess what? If they're going up by 2 units, it's going to be n plus 2. Whatever n is, the next positive even integer is going to be 2 units or 2 integers more than that. And the third one will be the original n, will be another 2 more, so I'm just add 2, right, to the previous one. Or plus 2 is actually just n plus 4. Okay. Right, and this is your legend. It tells you all 3 numbers we're looking at. And now that we have this, we can actually try solving the question by setting the equation here. Okay, find 3 consecutive integers such as the product of the second and third integer is 20 more than 10 times the first. Okay, the product of the second and third, which one is that? Well, the second one is over here. It is, right, that's the second one. I'll just circle it. Product means multiply. Okay, I actually notice I'm running out of time on this video, so I'm actually going to pause right here and continue where I left off in the next one. Okay, be right back.